purpose of this video is to be practice with the things that we did in the previous one. So I'm assuming that if you're watching this video, you've tried the homework problems, you've tried the assignment problems, you've checked some of the answers, you're getting them wrong, and you're wondering what's going on. Or that you just want to see a few of these before you dive into the problems. So I've got problems set up on the next page. The first one I have starts with some assumed information. This is a very common problem. They say if the log base a of 5 is 6 and the log base a of 3 is 4, can we find these things? Right? And the idea is, so like in this first one, you've got the log base a of 15. How can the properties of logarithms help us get from the log of 5 and the log of 3 to the log of 15? Well, the idea is, because 15 is 5 times 3, we can sort of see this as well. This will be the log base a of 5 plus the log base a of 3. And then because we know these things are 6 and 4, we come up with the fact that this log is 10, right? This first step here is really just me using that first property of logarithms and breaking that 15 down into 5 and 3, right? The one to the right of that is a little bit more complicated, but not by a long shot. This is the log base a of 5 plus the log base a of 9, because 5 times 9 is 45. And then I'm going to use actually the power property. Right? What I'm going to use here is, I'm going to write this as the log base a of 3 squared. And the thing that's great about that is that then I can take that second power and bring it down to the front of the logarithm. So this is going to get me the log base a of 5 plus 2 times the log base a of whatever 3 is. And fortunately, those are pieces of information that we know. From the beginning of the problem, we knew that the log base a of 5 is 6. So this is 6 plus 2 times. And then the log base a of 3 we knew was 4. So I can put a 4 here. This gets me 6 plus 8, which is 14. Right? And the third example I have here, the log base a of the cube root of 5. This one is really, really important. This one highlights that idea of, do we remember that a root is actually a fractional power? Do we remember that we can write this as the log base a of 5 to the 1/3 power? Assuming you remember this, this should be easy, because now we can use the power property to bring down the 1/3. This is 1/3 times the log base a of 5. And then, because we know the log base a of 5 is 6, this thing is just going to be 1/3 of 6, which means your final answer is going to be 2. Right? So these were some examples of us using these logarithms for us to come up with answers for problems. The next slide is about condensing, I think. Yeah, so condensing logarithms. And this is, I don't know if I want to say it's more important than the previous slide, but I feel like we use this more than what we did on the previous one. It's just this idea of, look, I may not have numbers for these things, but I should still be able to condense these things and get them into one log expression. And a lot of what this is about, and I mentioned this in the second video, is it's about order. We see a subtraction symbol here. We'd really like to do the division property, but that can't be done if there's a 2 in front of this thing, right? Move this all back. If that 2 is in front of here, I've got to move that up first. So I'm going to rewrite this as the natural log of 8, I'm sorry, not 8, but 9, 3 squared, minus the natural log of 7. And now that both logarithms do not have anything in front of them, I can use the division property and get that this is the natural log of 9 over 7. Right? And that's all I'm looking for there. The problem to the right of this is a little bit sneaky. On the one hand, you know, we all see that third power is going to go up on this thing, so we'll end up with negative natural log of 8 plus the natural log of 10. But one of the more common mistakes I see people making is they're like, oh, there's a plus, that means I can multiply stuff. You know, maybe they would say, oh, there's a 10 and an 8, oh, and a negative, so it's the natural log of negative 80. Absolutely not. This negative does not get pulled into the 8. In fact, I personally kind of think that the best way to see this problem is to rewrite it. To see this as the natural log of 10 minus the natural log of 8. Because I think when you see it that way, you'll realize, oh, this isn't actually an addition problem. This is actually subtraction in some sense. Which means now I can rewrite this as the natural log of 10 over 8. Or I suppose we could even rewrite that as the natural log of 5/4. And that's the answer I'm looking for. There is technically another way to do that one, and since we're in practice mode, I'm going to actually slide sideways and show that to you. Some people right at the beginning would have said, hey, why don't we bring that entire -3 up as the power? Right, what if I just don't even leave the negative in front, just bring it up as the power? If you did that, 2 to the -3rd is 1/8. And now, in fact, it's not a subtraction problem at all. It's actually an addition problem. And that means we can multiply what's inside those two things. This will be the natural log of 1/8 times 10, which is 10/8, which totally gets us back to the same place. So if you would prefer to see this as me taking a negative power and bringing it up, that's fine. That also works. You can do it either way. As long as you're careful with the math that you're doing, that's certainly legal. So now I've got these two problems here. The first one here is hopefully fairly simple, but there is a bit of a twist in it. Because this is subtraction, we know we're going to want to divide. But what I'd rather you guys not do is I'd rather you not say, oh, this is the natural log of 2/3 over 4. I'd almost like you to think of it as this is 2/3 divided by 4, but instead of dividing by 4, let's multiply by the reciprocal. Like, I understand this is going to be divided by 4. But because we're dealing with fractions, it may be more reasonable for me to do 2/3 times 1/4. And that can even simplify a little bit. This will drop this down to a 2, and I'll end up with a natural log of 1/6. And there's our answer. Just woke up, which means we may have some interruptions in these last few problems. He's playing with his iPad in the other room. We'll see how that goes. This next example I have, again, it looks a little dangerous because you've got this minus here, so people think like, oh, we need to divide these things. I think my take on it is when you've got a problem that's got multiple negatives, it may make sense for us to actually factor that negative out. And when you do that, you notice, hey, this whole problem is actually positive. I'd have the natural log of, bring this up, that'd be 5 squared, 25, plus the natural log of 7. And so now you've got the negative, and now if you combine those two things inside, the natural log of 175. And we can either stop there. I know I've got more problems underneath this, but that's okay. We can either stop there and say, yay, this is good, or we could take this -1 power effectively and bring it up. We could also end up with the natural log of 175 to the -1. In other words, 1 over 175. Either one of those answers is good by me. It's, as always, multiple choice can kind of go anywhere. We need to be prepared for whatever they have. These last two problems I'm hoping are going to be pretty quick. And then I've got one last slide of practice. This one here is supposed to remind you of that change of base formula. When you've got one log over another log, they both have the same base. Remember that you can rewrite that as one log by using the log base the bottom of the top. The log base 6 of x. So in this next example, you've got, both of them have this half in the front. And so we know before we do anything, we're going to have to take that power and move it up before we condense any other way. But I do want us to remember when you take a half power and do push that up, that's effectively a square root. So this is going to be the natural log of the square root of x plus the natural log of the square root of x squared plus 1. Now that I've gotten rid of the things that are in the front, I can use the addition property to multiply the things that are inside, and this is going to get me the natural log of the square root of x times x squared plus 1. And that's our condensed answer. The last example that I have on the last slide is this is actually going the other way around, where we expand a logarithmic expression. So they've given you something that's in one log, and we want to separate it out. And I know a lot of people are like, look, why are you having me do both of these? And the answer is because we do different things in different places. A lot of times we'll do the condensing, which was the previous thing. We'll do that at the end of the problem to simplify the answer. But a lot of times we'll expand the thing in the beginning of the problem because it'll make the problem a whole lot easier and nicer to work with. At the moment, you're gonna have to trust me. By the time we get to the first or second lesson of the real chapter, 5.1 and 5.2, I hope I will have convinced you of the value of expanding and condensing logarithms. So the first warning that I have to give here is, we see this power and we're like, yeah, I want to bring down to 2. We see this square root here and we're like, yeah, we can bring down to 1/2. That's great, but you can only do that when the power applies to everything inside of the log. So currently I can't bring down this squared because it's not squaring this. I can't bring down the 1/2 power because it's not applying to this. The first thing I need to do is I need to split this into the log of x squared plus the log of the square root of x plus 3. Now that I've done that, this square is applying to this whole thing. This 1/2 power is applying to this whole thing. I can now bring the 2 and the square root down to get 2 log x plus 1/2 log of x plus 3. And that's the best we can do. This is it. It's been expanded, and we're done. I hope that practice gives you what you need to get through the assignment for tonight. If not, have your questions ready for class when I see you.